Hi, I'm Liz Alvarez. I'm a data scientist at Dick's Sporting Goods. I work on the e-commerce search relevance team. Before I was a data scientist, I was a math teacher, and in the long ago times, I was an electrical engineer. But now I mostly work on NLP projects, which is why we're going to be talking about language today. So there's a theory called the Sapir-Whorf hypothesis that says language influences how we think about and experience the world. So this little stick figure here speaks American English. Sees an eagle and thinks to himself, majestic, proud, free. So the eagle is still the eagle, like nothing has changed about the eagle, but the language that he knows is the lens through which he experiences that eagle. So those are the words that he puts to it. In other words, the big idea for this speech is the question is not what you look at, but what do you see? So basically, the Sapir-Whorf hypothesis talks about how habits in our language become habits in our thoughts. It's a relationship both ways. So thoughts affect culture, culture affects language. It kind of goes in a cycle. So we're going to look at two different languages on this slide. We've got Japanese and English. I only know a little bit of Japanese, but I'm going to try. So the Japanese, the first line says, Tokyo ni sundemasu ka, which is, do you live in Tokyo? And the second line is, Tokyo ni sundemasu, which is, I live in Tokyo. And the only difference between those two, I tried to color code it so it'd be easier to see, that green symbol at the end of the Japanese is ka, and all that means is that it's a question. So everything else is the same. Like, do you live, Tokyo, those are all the same. So the things that are missing are the pronouns, because Japanese is a language that often drops pronouns, but English never does. So it turns out that in languages that drop pronouns, they're usually related to cultures that have a more collectivist value, where, like, on the flip side, English does not drop pronouns, and so we value like individualism more, which is reflected in our language and our culture. So another example of that is gender. Hebrew is a language that is extensively gendered. When you're saying the word you have to be specific about, is it you a female, is it you a male? So you female is at, you masculine is ata. But then on the other side of the spectrum, we have Finnish that doesn't have many gender markers, or any, as far as I could find. So they don't even have separate words for he and she. It's just han for like that person over there is doing something. And then English is somewhere in the middle, because we've got he and she, but we don't have like separate U's depending on who you're talking to. So it turns out that when gender is a huge part of your language, it also becomes more a part of your thought too. So they did research and they found out that Finnish-speaking children figure out their own gender about a year after Hebrew-speaking children, and then English children are somewhere in the middle of that range. So these are all like first languages that I've been talking about. I'm getting to the programming thing, I promise. So second languages, right? Because we don't speak programming, and like nobody speaks Perl as their first language, or Python as their first language. So basically I wanted to see, does this hold true for your second language? So like if you already have your natural language, does your culture stay the same regardless of what other second language you have? But it turns out that if you switch to a different language, your implicit attitudes can also switch. So they did a research study on Arabic Hebrew bilingual speakers, and they found when they asked them questions in Hebrew, they had more positive attitudes towards Jewish people. So what this means, big idea, is that changing languages can change your thought patterns. So going to programming now. I mentioned before I was an electrical engineer, and the language that they loved to use in my classes was LabVIEW, which is so great for electrical engineers, because we had this way of thinking that there are these components, you wire them up, everything works, it's great. And so you can see this LabVIEW program is the same thing. It's got the components of the triangle, the base, the height, the area, and then there's even a spool of wire under that, the pointer hand right here. This is a spool of wire, so you literally wire the components together. together. So electrical engineering, we were very much like, here's all the chips, you put them together, and then there's a program that works, and it's great. They've got like loops and everything in there. So this is one where like coding and thoughts reinforce each other. But now looking at some other programming languages, so I've got PHP and OCaml up here. They're doing the same thing. They're adding the numbers 10 and 20 together and then printing out the sum of those numbers, but they look very different. PHP, you just add the numbers together and then you just like say what the sum is. But OCaml is, you're adding an integer, which is 10, another, like 20 is also an integer, and when you add them together, you get an integer. And then when you want to change that to a string, you're changing an integer to a string. So like the types are very important in OCaml. With PHP, like you can make a mistake in the types, but like it might give you some garbage results, but it'll give you something. But OCaml, if you mess up anything, it's not going to work at all. So it turns out that PHP was what was used to build Facebook, and they wanted to do it fast, and it was like a personal project. They were just trying to look at like the girls at their college. But OCaml was much more intentional for Jane Street hedge fund, where they needed to be correct, because you do not want to mess with people's hedge funds. That is not a good idea. Here are some nice little quotes about those two languages. So PHP is about moving fast and breaking things, and so the culture around that is like you just want to get it down and do it fast, and like if it breaks, that's fine, we'll fix it, whatever, and like move on. But OCaml is like very much like it's intentional, and so if you do it enough, which I have not, just looking at the code is like annoying to me, but like if you do it enough, you kind of internalize that, and so you almost like can't even think bad thoughts because OCaml doesn't want you to. So I just wanted to go through a couple other programming languages. This is just a 10-minute talk, so I'm probably not gonna hit your favorite language, I'm sorry, but I tried to get like some representative like big ones. I also wanted to start with my favorite language. So Python is very flexible, minimalistic. You don't have to worry about semicolons, thank God. I learned Java and that was like, ugh. But it encourages you to focus on the logic, which is great for data science because I just want to train my model. Like I'm not concerned so much with the like formatting of the program. Like I want it to do the thing I want it to do. Yeah, that's Python, and because of my math background, I feel like I tend to use it in a more functional manner, but it's flexible. You can do object-oriented programming with it too. C# is more object-oriented, so I feel like this one, you're good at breaking things down into like smaller pieces and then adding in the complexity with inheritance, with different methods, different objects. So you're thinking about the relationships between things, whereas Python, maybe you're not doing that so much. Or you could be if you use it object-oriented wise. And then we have SQL, which I have to use. Somebody mentioned yesterday that data scientists write bad SQL statements, and well, it's probably true. So SQL is more declarative, and you're thinking about sets of things and including things and excluding things. So it's like asking, so I have a 4-year-old, and when he asks me to make him a peanut butter sandwich, like, can I have a peanut butter sandwich without the crust, not the grape jelly, not the wheat bread? Can you use the bread you bought yesterday, not the bread you bought last week? So it's very like inclusive, exclusive. What are the things you want? What are the things you don't want? Compared to like the normal make a peanut butter and jelly programming example that we use. So with this, yeah, you're thinking more relationship-wise and like groups of stuff. And then this one, if you haven't heard of it, it's fine. I just picked an esoteric programming language, and my daughter loves cats. So this is the one that I picked, lol code. It is very basic functionality. I don't think you could do a whole lot with this. It's playful. But the point of these programs is not to like do stuff, it's to look cool. And my daughter's 15, so that's like her whole existence right there. Yeah, those are actual like commands in that language too, everything in that picture, yeah. It's a trip to read a program in this. So basically, when you're thinking about programming languages and how they affect your thoughts and your habits, if you want to be intentional about it, these are some questions you can ask yourself, like what does this language make it easier to do? What does it encourage me to do? And what does it discourage me from doing? And also, like, do I like the type of code that this is making me write? Because those habits are going to get internalized into your thoughts some, so you have to be really like intentional about it. And that was a little bit more than my 10 minutes, but thank you.